All right, today we're going to talk about reflections on the coordinate plane. So a reflection flips a figure over a line of reflection in order to create a mirror image. So a reflection flips a figure over a line or a line of reflection, a line of reflection in order to create a mirror image. Each reflected point of the figure should be in the same distance away from the line of reflection, but on the opposite side. So this blank is reflection. All right, so let's look at the first example. This one says reflect the triangle WXY over the y-axis, and then we'll answer the questions. So let's record the coordinates of the pre-image first. So W is 2, 6. X is 7, 4. And Y, oh, let me fix this. This is W, X, and Y is 2, 2. So if you're flipping this over the y-axis, it should be on the other side of the y-axis, but an equal distance. So this is 2 to the right, W, so we're going to make this 2 to the left and call it W prime. So W prime's coordinates are -2, 6. X is, start at the axis, 1, 2, 3, 4, 5, 6, 7. Right of the axis, we're going to go 7 left. 1, 2, 3, 4, 5, 6, 7. So that's X prime. So my new coordinates are now -7, 4. And our Y is at 2, 2. So instead of going right 2, we're going to go left 2. So that is Y prime. And my new coordinates for Y prime are -2, 2. So you're going to connect those. Same shape, just flipped over that y-axis. So if you're going to describe how the reflection affected the x and y values, well, the x values become the opposite. So if you look at W, it's 2, 6, and W prime is -2, 6. So your X values become the opposite, and your Y values stay the same. How could you represent a reflection over the y-axis algebraically? That's that transformation notation that we talked about yesterday. So X and Y, when they're are transformed in a reflection over the y-axis, the X becomes negative and the Y stays the same. All right, let's look at the next one. This says reflect triangle DEF over the x-axis and then answer the questions. So let's record the coordinates of our pre-image first. So D is at 2, -2. E is at 7, -7. And F is at 2, -7. It doesn't look like a 2. There, 2, -7. All right, so now we're flipping it over the x-axis. So your points should be the same distance from the x-axis, but instead of down, they should be up. So D is 2 down, so we're going to make D prime 2 up. So my new coordinates are +2, 2. E is 7 down, so we're going to go 7 up. So E prime is at positive 7, and F prime, instead of going down here, we're going to go up. So it's going to be at 2, 7, and this is F prime. So 2, positive 2, positive 7. So to describe how the reflection affected the X and Y values, we'll look at the X, and the X values now stay the same, while the Y values become the opposite sign. So they became opposite. So if you are reflecting over the X-axis, your Y values are the opposite. If you're reflecting over the Y-axis, your X values become opposite. So here is our transformation notation for that. This time, it's our Y value that's the opposite. Oop, let me connect these. Make sure my shape stayed the same, but flipped over the other way, making a mirror image. All right, let's go to the next page. All right, so here is a picture of a reflection for you. So give a verbal description of the transformation. So we can say triangle PQR is flipped over the y-axis or reflected over the y-axis. Give an algebraic representation of the transformation. So this is over the y-axis. So when you go over the y-axis, the x changes. So I have the point x and y, and the x coordinates change to the opposite while the y stays the same. List if each one of the following changed or stayed the same. The size of the figure, that stayed the same. Still the same size, but flipped over. The orientation of the figure, that changed. And the orientation of the vertices or the points, that also changed. All right. Bella believes the graph shows a translation down, while Scott believes it shows a reflection over the x-axis. Who is correct? Well, Scott is correct, because if you look, the O is no longer at the top. It's at the bottom now. So the orientation of the corners of vertices has changed. So Scott is correct because the orientation of the corners or vertices changed. So good job, Scott. All right, number 5. Triangle ABC has the coordinates shown in the table. Miguel is going to reflect the triangle using the rule. The x coordinate turns the opposite and the y coordinate stays the same. So when your x coordinate changes, we said that is a reflection over the y-axis. And let's list the new coordinates. So your x is going to become opposite. So your a prime is now 4 and your y stays the same. Your b prime is the opposite. So instead of -5, it's 5 and your y stays the same. C prime, your x changes to the opposite, which makes it 1 instead of -1, and your y stays the same. So use the description to identify the line of reflection and write an algebraic representation of the reflection. So point A started at 8, -1. And then it was reflected to A prime where it's -8, -1. So your x changed. So that means it's a reflection over the y-axis. So your x changed. And the algebraic notation for that is -x, y. Your x changed. a figure is reflected from quadrant 1 to quadrant 4. So if we went from quadrant 1 to 4, that's a flip over the x-axis, because remember, we have 1, 2, 3, 4. So if it flipped from 1 to 4, it went over the x-axis. And your algebraic notation is x, and your negative, your opposite of your y value. So point Z started at negative 5, 7 and is reflected to the prime, Z prime, negative 5, negative 7. So this time your y changed, so it's a flip over the x-axis, a reflection over the x-axis, because your y changed. And here is your notation. Your x stays the same, and your y is the opposite. And that's it.